as well as regionally, that is still still moving the industry forward. So we see that transition is still ongoing. And clearly, any decisions we make on technology and fuels today will shape the outlook and the fleet profile in the next couple of decades. So let me get down that there. So what I will try to cover today is a little short introduction on sort of technology and background on wind assisted propulsion. What do we see on the market update on types of wind assisted propulsion technology that we already have sailing around the world, literally, as well as sort of the different segments and how this is shaping out there as well. Also, the importance on the factors affecting the performance of wind assisted propulsion and how performance should be validated as well. Looking at sort of the issues regarding technical feasibility and regulatory overview, as well as the class rules that needed to be in place to support the safe implementation of technologies. And finally, also how DNV is supporting and can support the industry on this interesting technology. Also put a little QR code there on our white paper that came out last year. So, of course, we will share the slides there. So power wind, yeah, next slide there, go one step forward there, Wilma. Let's see. Yeah, as I said, the benefit of wind is, of course, that it's free, it's available. It doesn't cost anything to use it except for the cost of the equipment. It also, of course, varies a lot on the different trade routes in the world, which one is more prevalent and give most benefits. But the good thing is also that in some of the more common trade routes, there are definitely wind that can be applied. And we also see that on some of the early adopters that they carefully evaluate which routes and trades that would be more useful to leverage the trade winds with this technology. Next one. So, of course, there is a multitude of different technologies that's already in place on the wind assisted propulsion. So we see different types. These are some examples of early adopters and common systems, but we see there's a multitude of different manufacturers and systems that's out there. Generally, of course, the fuel and the reductions we see varies a lot between the different ships and trades, but generally you can see we see anything from 7 to 30% fuel reductions can be applicable for these types of technologies. Next one. So not to be too technically, but a little bit sort of just a principle between how wind assisted propulsion and the new wind sort of use works. It's basically use the principles as the standard airfoil and is depending on the incoming wind direction and angle of attack. The airfoil or the wind will basically produce a lift because of the pressure differential between the low pressure side and the high pressure side that's generated as the wind speed changes as it moves across the foil, and that creates a lift force, which is translated into a thrust force for a vessel, but also some drag. And generally, you can see that the aerodynamic efficiency is sort of defined as the ratio between the lift and the drag. So if you look at how that is applicable on a ship, so the next one. So you have, of course, a total resultant force acting on that because of the lift and the drag. And if you sort of, on the next one, we put the ship below the sail. So that is then depending on, again, the ship's direction of travel in relation to the incoming speed direction, will result in a thrust force that act as assists the propulsion power of the vessel, but also a side force that has to be taken up by the foundation or the sails themselves. So of course the effectiveness of the sail depends on as well the wind direction as well as the heading of the vessel. So as you can see, if you go to the next slide, as the vessel direction heading changes, you might get more thrust and different side force. The resultant is still the same. So that's really how the different technology work, and also of course the airfoil shape might be different. Like say you use the rotor sail, which is kind of a circular type of sail, but it's still, because of the rotation, will generate the same type of forces. So the next slide. So yeah, as I mentioned earlier, the modern wind-assisted propulsion comes with many different types of technologies and designs, rotor sails, suction sails, wing sails, soft sails, and even kites. And they're all based on, cutting edge development in terms of advanced aerodynamics, make sure the employment of the sails, several, different sails on board the vessels, and how they're deployed and directed is controlled by modern control technology and smart systems, as well as, of course, new materials to make the sail strong but light and suitable for the vessel as well. The good thing is, of course, that as I say, that you don't pay anything for the wind. So as other, let's say, fuel technologies, you're not subject to the changes in the price of the fuel. So you have sort of a predictable investment in terms of the cost of the equipment and installation, and as well as some of the operational costs that might be included during the use of the sail. Next one. So I'll go describe a little bit about sort of the three main technologies, or that have so far had the highest uptake. So that's the rotor sails to start with. So in the sense of the rotor sail, as I say, it's based on it's called a Flettner rotor, based on the Magnus effect. So it's basically was invented by Alton Flettner in the 1920s, and it's a rotating cylinder that, as it spins with wind around it, it will generate a thrust force because of the pressure differential. It's the same effect as you have when you throw a curveball in baseball. A spinning ball will sort of generate its own force as well. So one of the benefits of that is they need a low power input. They need some force to rotate the cylinder, but it's quite efficient in terms of depending on the rotational speed, how much thrust it will develop. So it also in a way can have sort of a fail-safe behavior. If the vessel loses electrical power, it will the rotor stop spinning and no lift is produced as well. And of course, with most of the sails that we see today, they can also be tilted when you get into port operations, for example. So this is how the Flettner rotor and the rotor sails work. Next. The next technology that we see a large uptake on is suction sails. So they are typically aerofoils, but in order to have a higher angle of attack capabilities than just a fixed airfoil, they use basically a fan to suck some of the air on the leeward side, on the pressure side, low pressure side off a little bit, so some of the separation takes place later. So it'll have a little fan that sucks in and makes a quite efficient way as well. So similar to the Flettner rotor, it does require a fan operating in order to operate most efficiently, and that's at the same time can also be aligned then with the wind to get the best effect and have a sort of a longer range of operation towards the fixed sail as well. And again, it can also be tilted for port operation or to reduce draft when you do not have enough air to operate. Next technology is the wing sail. So again, this is a foil-shaped sail, operates like an airplane wing, but also sometimes with flaps or other arrangement to increase the lift or thrust. And it provides more aerodynamic efficiency compared to traditional sails, and it can be both rigid and semi-rigid or soft or hybrid materials. So using material technology to reduce the weight, but as they have a good durability, we see a lot of innovations on that between the different manufacturers as well. And again, also available in tilting configurations as well. So next one. So look at sort of where do you see on the market on uptake. So the data I'm showing here, it's from our alternative fuel insight platform that hopefully many are familiar with, where DNV support, where you can see the uptake of new fuels on anything from that is discussed in the industry, from LNG to hydrogen to LPG, methanol, ammonia, but also technology. So fuel cell batteries and now also on wind-assisted propulsion. So this is where we basically get data from confirmed sources and share that with the industry, and VAPS has its own module within our alternative fuel insight platform there. The next one. So today, from our data, we see as of today, we see 77 total ships in operation as of today, and of course there are also a number of ships on the order book, but this is what we see there. And you see there, as you can see on the technology uptake, rotor sales and suction sales has more than 80% of the market share today, with smaller shares of the wing sales and others like kites and more typical sail arrangement. We also see on the bar graph there on the development, and of course there's kind of been I wouldn't call it an explosion, but a sharp growth in the uptake from 2023 and forward. And we see that continuing in 2024 and 2025, and sort of transition from more of the retrofits to new building, which is of course also important, because when you make a new ship there, then it is also easier to adapt the sail to the right ship. And I see Alistair had a comment on the 108 vessels with 17-foot order, and yes, we are a little more conservative. Maybe we want to ensure that we have the data that signed contracts and these things. So, but yeah, the overall picture is similar. We see a good growth on the uptake of both the retrofits as well as the new building on the sails that are vessels with sails over there. When we see in the next one, we can look at sort of where we see on the segment sides, and as you might be aware, we see most of the uptake on the bulk carriers, the general cargo ships, and smaller oil and chemical tankers. Also a growth in the ro-ro cargo vessels, as well. And we see also some developments on the gas tankers and a slower uptake on some of the other segment on LNG, on the container ships, and car and passenger ferries, and for different reasons. But we see this technology also being developed for other types of segment as well. So I'll also go in a little bit on the performance verification and some of the factors that is affecting that. So one reason why this is important is if you look in the literature, you see a large variations in both predicted and achieved performance on vessels. So this is just a list of different papers or reports that we have seen, and it's clear there is definitely a large variations in the expected uptake. So if you go on the next slide, of course, a clear reason there is the fuel savings are influenced by many factors. So that, of course, will it's very specific to the vessel. So just please move forward, Wilma, with there is some bulls there. So of course, the ship size and displacement of the vessel has a large influence on the potential. The number and the size of the sails that you put on an individual vessel will have an influence on how much savings you can see. Then next one is, of course, also, as you said, the type of technology has a big influence on the potential, and how these are configured on board a vessel, the placement on the deck, because they might have, influence each other. So that also affects the performance. And next one is, of course, the trade route that they're operating on, and certain voyages, certain trades will definitely show a lot more potential than other trades. Next one. And of course, there's also a combined effect on the hydrodynamics on the vessel, the hull form, the hull and rudder. So especially on retrofits and even on new building, the optimization of the hull and the rudders can also influence the performance. And last one as well, on the machine and propeller, if you get some added propulsion power from the sails, it could affect your optimal performance point on your engines as well as your propeller. So all these factors are critical in order to understand the best performance that you can get out of your sail. Next one. So for any sort of measurement or verification, you need certain sort of basic issues. So you need, of course, to have access to accurate data, good sensors that can fill the requirements or whatever measurement standard you apply to. It's also important to have openly available, accurate, and transparent standards that between the technology provider and the operator can be used. So, and also we do also see there is need for independent third-party verification in order to ensure that contractual obligations or the reliable predictions are met as well, in order to compare model testing and analysis with real data. So next one. So you can see verification of propulsion. You can see there are two sort of complementary standards out there that we see. It's the ITTC recommended practice and guideline for evaluating the power using wind-assisted propulsion. So these are a standard that is based on sort of the ITTC regular guidelines on doing sea trials and under short term or minimum measurements. so adapted to isolate the wind-assisted propulsion performance under defined condition. The DNV recommended practice is not a competition to the ITTC. It's a complementary. They're both important and should be used in together often. But this is more an in-service performance verification designed for taking a number of measurements under statistical robustness and being able to compare or to get some data on the performance of the wind-assisted propulsion under different operating conditions, with different wind, different load conditions, different speed conditions. So taking a number of measurements over a longer period of time. Both standards are sort of based on the on-off type of measurements that you do a test with the wind-assisted propulsion on, and then one with off, or in the other way, and then you compare the performance with the system on and off, and then you will get enough data to make an assessment on the performance of the system. So the DNV RP is aimed at commercial verification for class and stakeholder confidence, and for owner charter transparency and financing and emission confidence. So bottom line, the ITC asked under control conditions, does the physics behave as expected? While the DNV recommended practice are what's the statistical defensible net benefit in real service. And as I say, in practice, we see projects are using both practices for baseline verification and model calibration, and the DNV RP is more for long-term verification claims. Next one. So why it's important to do on and off test? Of course, with traditional verification methods, the vessel condition, the vessel operation, environmental condition will always change. So it's better to do a test with the technology on and off at the same time. And you don't necessarily have to worry so much about correction to standard reference condition. Of course, with the on-off test, you assume that the conditions will be the same during the on-off test as well. Next one. So when it comes to, let's say, our recommended practice, it's sort of what is the benefit that you're trying to achieve while you wind-assisted propulsion. So next one, method one is sort of, you basically want to operate at constant speed, but you want to have reduced power from your engine, for example. So then your calculated quantity will be the power saving that you achieve when you are using the wind-assisted propulsion. You could also, of course, have a desire to increase the vessel speed while keeping the propulsion power constant, and then the calculated quantity is more on the power by sailed distance as well. Next one. So some of the experiences or observations that we have seen when we assist customers or stakeholder when doing verification assessments is, of course, it's important to have complete data sets and time series when taking measurements. For example, our recommended practice is you don't need a specialist equipment or specialist people on board. So it's important that the vessel's sensors, the locations are accurate, and they are also able to produce good results. But of course, when it comes to the sensors, the speed through water measurements becomes very important. The wind, both the wind direction and apparent wind speed, where those sensors are located and in relation to the sails becomes important as well. And of course, to accurate shaft power measurements is critical as well. Often we see, torque measurement, torque and speed measurement might be better than, direct power measurements, but again, it depends a lot on the technology as well. And the last one is, of course, that for our recommended practice, it's often that the crew or the people on board can do these measurements consistently by themselves without necessarily having anyone on board to conduct the measurements. So then, of course, it's important to have a good plan and a process on board and even training before these kind of measurements are started. So to obtain stable measurements and obtaining a new baseline for the on and off measurements every time you do a new set of measurements under a different operating condition. So this is important. So go a little bit on the technical feasibility and the class rule and standard. So the next one. So of course there is to understand the sort of the terminology of rule standard, we must sort of appreciate the operational challenges which must be addressed for successful implementation of the system. So the security of a specific project highly affected consideration the owner must address in a feasibility assessment and help bridge the gap between the concept and practical implications. So this is a lot of different consideration that you see on this slide, but installing WAPs on board a system as a certain requirement to the structure and design, and will have implication for the operation as well as compliance with safety and environmental regulation. Exactly which requirement implicate are relevant depend a lot on the different projects and the characteristics. And this is, we kind of looked at all these different issues here in sort of a random order, but the importance of each one depends a lot on the different characteristics. But typically, we can see it depends a lot on the ship type and size, different vessel classes, and their main particulars dictate varying technical considerations and constraints. Whether it's a new build or retrofit is of course very important, and the type of apps and what is the targeted installed power as well. So I do see that if you go on the next one, of course there are certain requirements, statutory requirements that are important. So SOLAS, the regulation convention, so that sets for example requirements to line of sight visibility, for example, as well. SOLAS 5 regulation 22, so obstructions like sail could impact that as well. So these things has to be considered early on, and whether there is any requirement, let's say, for cameras to improve visibility, and also whether or not the system is tiltable, and even all class society, even DNV has let's say stricter class notations on nautical safety, and those class notations might also set more stricter requirement to visibility as well. And another important part when it comes to statutory requirements is, of course, the location of navigational life, radar equipment, life-saving equipment, and these things that also needs to be considered, and might also then need flag state verification and approval in certain cases. Next one. Of course, a very important part is how you integrate the VAPs and the structural integration on board, both in terms of strength, but aerodynamic efficiency. For tankers, there is an issue. How can you place this equipment in hazardous zones, as they typically will have electrical equipment installed in well? This has to be considered. What is to say the line of sight? How does it affect the vessel's maneuverability? And then the structural integrity, and often some of these are equipped with bearings for tilting or hydraulic equipment, and all these things need to be considered early on the stage. And as I say, for new building vessels, it can be easier to integrate the installation of sails on board the vessels than trying to retrofit vessels. So next one. So if you look at the technical feasibility system, so if you look at the design, as I say, what is the free air and deck space that's available, the structural integration, the intake stability, the installation on hazardous zones, we already mentioned as well. But of course, the added weight, what is the air draft? Is there any limitations on the route, and say bridges or other things, or port operations that might affect the choice of technology and number of sails, and as well as mooring configuration. And of course, the importance of performance optimization in terms of the sails, but also the hull, the machinery as well. And you already mentioned the navigational risks that has to be assessed as well when installation of sails. When it comes to the operational consideration, yes, how is the reliability? What is the operational safety? How can you maintain and repair the systems as well? What is the interference with deck and cargo handling? We see that as a concern, and from depending on the routes, and especially on the bulk carrier, how the port operations can be done efficiently with the sails. Is there any need for engine propeller derating, maneuverability? Crew education training is of course critical with any new technology, and the same is true with wind-assisted propulsion. Port operations, how to engage with pilots is a kind of new technology that people are not familiar with. Some ports will welcome them, so other ports might be a little more reluctant, for example, as well. But all of these things come into place, and of course, sort of interference with any life-saving helicopter, these kind of as well. So again, the ship type, the size, there is a new build retrofit, the type of technology, what is the target installed power and the trailer out is critical considerations as well. Next slide. So on the technology, we often see this sort of three-stage verification process. You often start with a hazard quality risk assessment early on to identify any vessel route specific risk that has to be considered, and how that could impact the installation as well as the cost, and if there is ways to mitigate some of those risks that's identified. We also see on technology that manufacturer might look for some type of approval principle. Today, I think we see more and more manufacturer going for type approvals for their system, and then have that as a starting point for the integration of the technology on board a vessel as well. So that's sort of the next step after the certification of the equipment is, of course, the process to integrate it on board the vessel. Next one. So on the DNV side, we of course have the additional class notation WOPs, and that is one part of our regular rules for classification in ships, which basically talks about the integration of and adoption of the wind-assisted equipment and associated systems on board a vessel. But of course, a key ingredient in this is sort of the certification itself of the wind-assisted propulsion system before that. So those two standard, the component certification together with the rules for integration on board a vessel are hand in hand. So if you go on the next slide, you can see that, yes, we see more vessel. So if you're on the right-hand side, do the certification of the unit according to the DNV standard 0511, and that defends certain operational envelopes and material design road on the equipment, as well as structural analysis of the unit itself. But then, of course, with that type approval, then there is the integration on board the vessel itself that has to comply with the vessel and all the different systems aboard the vessel as well. So that's the process of having a certification on the wind assisted propulsion for a specific design. Next one. We also see interest in, wind assisted propulsion system ready notations. So again, as with any sort of ready notation, there are different qualifiers where you might just have a vessel built at the new build stage with structural enhancement and analysis to ensure that it can be installed. But then you can also do stability analysis. You can have navigational communication requirements already implemented before the sails are put on board and prepared for installation, except to hazardous zones or electrical installation. We do see some vessels basically going directly from the new build yard to another yard and where the sails are being installed as well. So I think, again, there are different ways that an owner or a yard can integrate the technology. Next. How can DNV support? So as I say, we have our certification classification service, the approval principle, type approval, design certification of the technology itself. And then talked about the additional class notation, wind assisted propulsion, and that follows our class rule, and also the ready notation is available from class. We also have our own class independent advisory services that assist with, let's say, fleet screening, looking at where different trade patterns or vessels can be most useful for wind assisted propulsion. But then also to more the early concept, to more detailed hydrodynamic analysis, using WAPS as a plan on the decarbonization plan, the strategy, help with the structure analysis, the performance verification after installation as well, during trials in the long terms, as well, of course, the early risk assessments and any influence on noise and vibration, for example. It could be reduced, let's say, even vibration because you have less propulsion load. Even underwater noise from the propellers could be influenced by wind-assisted propulsion. Next slide. So yeah, fleet screening. This is something we rolled out recently, basically, where we looked at, the world fleet of vessels are maybe 200,000 vessels, but in reality, only a fraction of them would be relevant for wind-assisted propulsion. But maybe next decade we could see, several thousand vessels with sails. But an early stage assessment based on AS data and wind loads around the world could sort of give an indication on which vessels and routes might be most relevant for retrofitting or building with wind-assisted propulsion. So that's sort of the first stage in a sort of a three-stage rocket that we look at, sort of in this facilitating the increased uptake with first a fleet screening and then a more high-level selector of what types of WAPs could be used and potential savings based on more detailed assessments. And then for you go in more sophisticated or detailed analysis and integrate into how WAPs can be used with all hydrodynamic and propulsion aspects and a lot of input from the makers as well. And again, it's to help the industry ensure reasonable payback period and help make the decision easier for owners and charters before they move to the next step. So, yeah, that was all I had. I see there is a number of questions that come in the chat, and hopefully we'll have some time to go through some of those. But yeah, I think it's important that we're able to scale up the uptake of these new technologies, and I mean, assisted propulsion could definitely be an important part of decarbonization shipping. That's our firm belief. Thank you so much.
Thank you. So Jan Hagen, do you just want to start by addressing the questions on the chat?
Yeah, we could do that. I guess we can kind of start maybe from the beginning. So let's see here. Yeah, so Alistair had his the numbers from the International Windship Association. I think I addressed that as well. That yes, they're I also see, you know, up to 100 orders on different or vessels in sale there. Hopefully, also in our AFI, we will also have the order book there eventually. We're working with the manufacturers and to get all the validated data in there before we put it in there. So yeah. From Barun, I think the reason, obviously, it's not only rotor and suction sail. We just see that that's have been the majority, and I think that's in terms of sort of the performance, the installation, and the efficiency of that has been more prevalent so far, at least, that these are the more popular technologies. I think retrofit numbers coming down. I think yeah, I think it's of course partly could be driven a little bit by the sort of pause at the net zero framework and people that had plans to do retrofits maybe say, okay, let's pause that a little bit. But I think it's also positive in a way that we see the new building orders are still coming in, and of course that might also give more predictability of the payback period, which is important when you make the commercial decision, and with new buildings, you might have more predictability, at least on the installation cost, than you would have on a retrofit. And yes, climate change affecting. Yes, I think so. You know, generally, I think a lot of the data is, of course, historical data is based on the wind in the past, and these could change. I think also we see, you know, better data, even satellite data coming in to see the changes in wind. So I think, yeah, better data, real-time data, wind, both from the vessel but also from other sources, becomes important to evaluate how this could potentially change. It's fairly easy to. I think it depends. I don't think it's to say it's easy. It depends a lot on the ship, but I think hopefully through the presentation you see there's a lot of considerations and factors that affects the retrofit suitability of vessels, and especially the type of vessel. Yeah. Crew training, yeah, as I mentioned, it's critical for any technology, and even so with wind-assisted propulsion, you know, they need crew training. Of course, a lot of systems are made to help the decision making when to implement the sails and how to use them. But again, crew training is critical both on the operational maintenance and the risks of using this technology. Is there a minimum speed? No, again, it depends a lot on I think, the vessel. And again, I think the optimal speed or wind that it used depends a lot on the sail that's being used and the ship and where they sailed. So we do see a few vessels using only wind as a propulsion, but I think what we hear from the industry is still that the wind-assisted propulsion is probably the most relevant usage of these type of modern wind-assisted wind propulsion technology for now, at least. So third-party validation, verification. Yeah, I mean, I don't want to necessarily dig too much in the word there, but verification, validation, yes. If you prefer to use validation, that's fine. Darren, here, squat and maneuvering characteristics. Was that maybe sort of a comment or more one of the factors affecting the performance? I don't know if you are.
I meant is, does it affect squat and the maneuvering characteristics of the vessel?
Yeah, I think short answer is yes, it can do. So this is one of the factors that need to be considered. Yeah.
Thank you.
Yeah. And one more from Varun, service measurements. How is the actual fuel saving derived from perhaps considerability of other savings? Yeah, Varun, can you elaborate a little bit? Do you mean how you can separate the fuel saving from VAPs towards other technologies that's been implemented at the same time?
Yes, yeah, and that's exactly what I was asking. Generally, all these upgrades are happening in packages, at least on the retrofit situation, where you also do bow, propeller, the latest anti-fouling paints, and then the ducts, PBCFs, and then you put a rotor on top. But your measuring systems is still the same. You have a torsion meter and you have a flow meter. So how do we really say that the VAPS is living up to its expected savings, as you showed in one of the slides, when so many things have happened on the same ship? So I was not very clear how do you distinguish between the two?
Well, I think both the ITTC sea trial guideline as well as our recommended practice is sort of based on this on-off methodology, that you first do some measurements with the technology off, let's say at a constant speed for a certain period of time, and then you turn the technology on for a certain period of time under the same condition, ideally, right, at the same time, and then by comparing the measurements before and after, you should be able to isolate the increase in or decrease, let's say, in propulsion power from your shaft when you use the sails.
Got it. Thanks, Jan.
Yeah. Alistair, see here. That they are using steady cams to get. Yes. Yeah, so Alice, you mean that the cameras are becoming more, yes, yeah.
I had discussed it with somebody at the previous Reno IWSA conference, and she had said that the pitch and roll were difficult problems, but they appear to have been resolved, so which is quite a breakthrough, I think. And also, they're basically operating higher than the bridge, so the radius of view is higher. And if you have infrared cameras as well, you get night vision. So those together with the AIS give you pretty good protection.
Yeah, good point. And I also know that DNV, we have a class guideline when it comes to use of cameras to get, to improve the visibility as well. So that sets some standards for use of cameras on board ships as well. So yeah. And Arun, our weather routing systems getting upgraded with WAPs. That I'm not really, I cannot really say for sure. Maybe someone else that are listening in are familiar with more the weather routing providers, if they have any sort of information on some of these that they use that. But I guess sort of forecasting of wind in general, I think are part of the weather routing services, and maybe some improvements can be used in sort of predicting based on the type of in the system that is on a particular vessel. But maybe the weather routing firm companies could elaborate on that.
All right.
Yes, and then Wayne, you had a question who you have to record the investments. I think it of course depends a lot on the savings that you achieve. Typically, what we see a ship owner or charter want to recover, they would look for a ROI on, let's say, 5 years, something in that neighborhood in order to move that, pull the trigger on it. And of course, any incentive, financial incentive that we see, for example, in EU, can help to make the decision. The net zero framework would maybe have something, but that is sort of gone away now. So at least now, but we see fuel savings can be significant, and a lot of owners are still moving ahead with this technology. The other thing to take in consideration is we do expect the prices to go somewhat down, maybe as produce or technology providers scale up their production supply chain as well, and that could help the business case as well as we get more experience with the installation cost, which is of course a significant investment as well. And as we get more experiences from the yards and ourselves and everyone on this, we get better at that as well. So,
and I guess the last question is any government incentives for adoption of technologies?
Not that I'm aware of, at least in terms of financial incentives.
Okay. All right. Thank you, Jan Hagen, for a very extensive and in-depth presentation. For those of you who might be busy taking notes and missed something, we will be putting both the video and the presentation on our website. So that will come out probably in the next couple of days. In the meantime, I will want to thank you for coming and thank Jan Hagen again. And hope to see you next month. It's Wednesday, April 18th, same time, 12 o'clock, online for evaluating alternative fuels for maritime transportation. So thank you all for attending. Thank you, Jan Hagen, and we hope to see you all again.
Thank you.
Thank you.